All right. If the equation of the regression line that relates percent blood alcohol to reaction time in milliseconds is this, what does that mean? Okay, so again, we're talking about slope and what this means. So we can say y equals 36 minus 0.13x. Where's the slope? Right here. The slope is the number next to x. So remember, whenever you have an equation with y alone, the slope is the number next to x. So, okay, so what? So the slope is negative 1.3. Negative 1.3, which means this, if you were to graph this line, it's a line going down. Negative slope down to the right, right? It's a line going down to the right. And what are the connections? What are the variables here? Well, it says percent blood alcohol, X. This is percent blood alcohol, BA, blood alcohol. I'll put AL, percent blood alcohol level. And Y, reaction time. I don't know. I don't want to bring up sad things, but I do like to show the relevance of this data. Just yesterday, my wife and daughter were telling me about my wife. My daughter works at a local racket club, and there was just a terrible accident. I think just yesterday or the day before, with a young lady who was drinking, and somebody died. It was very sad. And my daughter knew this girl and said she's a really nice girl, and it's just a super sad situation. Super, super sad. Anyway, and when you know, drinking and driving is serious business, and it's just so, it fools you so easy because you feel like you're fine. You just think, I'm good. I'm just going to drive down the road. I'm good. You're not good. This graph shows it. This data shows it perfectly, that as your blood alcohol level goes up, your reaction times go down. They just simply do. It's just the reality, and driving a car is deadly business. So the slope tells us that for every percent increase in blood alcohol, we can predict reaction time to go down by 1.3 milliseconds. That's exactly what that says. How we know that's a yes, that's a true on that, how we know is because, again, slope, remember what slope is? Slope is rise over run. So let me write this for you. Slope is rise over run. And so the slope is, and what is our slope? Right there. They think, well, it's not a fraction. You remember, you put it over 1. Anytime you have a whole number, you can put it over 1. That's the same thing. Negative 1.3 divided by 1 is the same as negative 1.3, right? Dividing by 1 doesn't change anything. If I go 10 divided by 1, that's just 10, isn't it? Dividing by 1 doesn't change anything. So if they give you a slope number and it's not a fraction, just stick it over a 1. Okay, great. So what? Rise. What is rise? Rise is Y values. What is run? X values, right? You run on the x-axis, you rise on the y-axis. So when they say rise over run, Y values, there's what? Reaction time. Reaction time. And what is the x-axis? Percent blood alcohol level. That's the x-axis. They told me that right in the words of the problem. So they're saying down 1.3 reaction time anytime you go up 1% in the blood alcohol level. Exactly. Down 1.3 milliseconds on your reaction time when you every 1% increase in blood alcohol level. It's a graph directly showing how your reactions go down as your blood alcohol level goes up. That's exactly what it's saying. How do we know all that? The slope is the number next to x. The slope is the number next to x. And slope is rise over run. Put that over 1. And what is rise? Rise is y. What is y? They told me right here. Y is reaction time. And x is blood alcohol. So down 1.3 reaction time for every 1% increase in blood alcohol level. Or it's a line going down, for graphs. Goes down to the right. Blood alcohol level going to the right, going up. Reaction time goes down to the right. Exactly.